which is denoted by kappa of t. Okay, this notation, this looks like k, but we'll pronounce it as kappa of t, is defined to be kappa of t at the point gamma t is defined to be kappa of t is equal to norm of second derivative of gamma at the point t. Okay. So what was gamma dot t? Do you remember? Norm of gamma dot t. What was that? So this was the derivative of arc length. Okay. So this is a unit speed curve. So norm of gamma dot t is 1. That's true. I'm talking about general curve. So since here we are considered second derivative, norm of the second derivative, I was just asking what was the norm of the first derivative. It was ds by dt, arc length, right? Derivative of the arc length. Okay, here it is norm of gamma dot t is 1. That's true. Yeah. So to analyze a curve, what we are studying is arc length, curvature. They are nothing but precisely we are studying its first derivative, second derivative, or they are no. Okay. So this is the curvature of a unit speed curve. So now, as I told you, we can define curvature of a regular curve. Curvature of a regular curve is defined to be the curvature of its any unit speed reparameterization. Okay. So we are starting with a regular curve gamma t. So by speed reparameterization. So by earlier definition, we can talk about curvature of a unit speed curve. So curvature of a regular curve is defined to be the curvature of its unit speed reparameterization. Okay. So now there is this interesting proposition which shows some expression for curvature of a regular curve. Okay. So proposition, let gamma t be a regular curve in R3, then the curvature of gamma t is given by simply k, or k of t is equal to norm of the cross product of its second derivative with first derivative divided by norm of gamma dot cube. Okay, fine. Please read the statement. We are given a regular curve, so we can talk about its curvature, and curvature is given by the formula k is equal to norm of gamma double dot cross gamma dot divided by gamma dot norm of gamma dot cube. Okay. Yeah. So at the point, or this means that at the point gamma t, this value you have to evaluate at all functions. K of t is norm of gamma double dot at t cross gamma dot t by norm of gamma dot t cube. So this cross product. So did you remember this cross product of two vectors? So if I have two vectors, x equal to x1, x2, x3, and y is equal to y1, y2, y3. This is in R3. Then what is x cross y? Did you remember? Cross product of two vectors. X cross y is a vector in R3 which is orthogonal to both x and y, which is perpendicular to both the vector x and y, and it is given by are the unit vectors x1, x2, x3, y1, y2, y3. Okay, this is from your vector calculus. X cross y is actually a vector. Yeah, even though I written it as a determinant, it means that this can be represented. This is same as, or this can be represented as a vector in R3 in the following way. You can forget about I, and this is x2, y3 minus x3, y2, I into determinant of this, right? And minus j into, so that it will be minus x1, y3 minus or plus y1, x3. Third component will be x1, y2 minus y1, x2. Okay, so this is from your lower classes or degree vector calculus course, cross product of two vectors. And in this expression of kappa is equal to norm of gamma double dot second derivative cross first derivative by this the cube of the norm of the first derivative. So this cross denotes the cross product. Okay, gamma dot t cross gamma dot t, gamma double dot t cross gamma dot t is a cross product of those two vectors. Okay, now let us come to the proof. So let gamma t be a regular curve in R3. So we know it has a unit speed reparameterization, right? So let S be a unit speed parameter of gamma. Okay. Then let us compute gamma dot t first. Gamma dot, this is nothing but d gamma by dt, right? Now S is a unit speed parameter of gamma, so gamma is a function of S and S is a function of t. This is d gamma by ds into ds by dt, right? Okay, so this is gamma dot is equal to d gamma by dt is equal to this. So this is one. Maybe we will compute yeah, maybe we can compute d gamma by ds from here. This will be d gamma by dt divided by ds by dt, right? Okay. Yeah. Okay. Now, what will be the expression for kappa of t? What do you know about kappa of t? What is kappa of t? Kappa of t is the curvature, right? Curvature, we know for a unit speed curve, curvature is nothing but norm of gamma of double dot of t, right? So this will be norm of d square gamma by ds square, correct? As S is a unit speed parameter for gamma. Okay, fine. When you see gamma as a function of s, it is unit speed. So you can, for a unit speed curve, its curvature is nothing but norm of its second derivative. Okay. Now let us do some computations. K of t is equal to, okay, norm of d square gamma by dx square. This is norm of d by ds of d gamma by ds, and this we can write it as d by ds of, okay, let us substitute from equation 2. This is d gamma by dt divided by ds by dt using 2. Okay, fine. Now you see ds by s is a function from open interval to real numbers. So s is a scalar valued function. So ds by dt is also a scalar valued function. So you can pull out this ds by dt, that behaves like a constant. So you can pull out. So this is 1 by ds by dt into d by ds of d gamma by dt. Okay, fair enough, because ds by dt is a scalar valued function, real valued function of a, or it is in this function s is depends only on t, or it is independent of s. Okay, ds by dt is independent of s. So norm of 1 by ds by dt one minute. Okay, so 1 by ds by dt is equal to d square gamma by ds dt, right? So this is same as 1 by ds by dt into this, I can write it as d square gamma by ds dt is same as dt ds, right? Because that functions are very smooth, so it is infinitely differentiable. So you can change the order of differentiation. I mean, first you differentiate with respect to s, and then t, that would be same as first with respect to t and second with respect to s. Okay, so this is norm of 1 by ds by dt d by dt of d gamma by ds. Okay, so again from 2 to substitute for d gamma by ds, that was d gamma by dt divided by ds by dt, again from 2. Okay, so norm of 1 by ds by dt into d square gamma by, now here, yeah, here you have to be more careful in the sense both are functions of d gamma by dt is a function of t, ds by dt is a function of t. So you have to apply what? You have to apply quotient rule, right? So first denominator into derivative of the numerator. So this is d square gamma by dt square minus numerator into derivative of the denominator. So d square s by dt square. Correct, right? So this is, I will rewrite this as this percent. Okay, and there is a divided by square of denominator, right? F into g, f derivative of f by g is g into f dash minus f into g dash divided by g square. So now what you can do? Yeah, so I'll write it in another form. ds by dt into d square gamma by dt square minus d gamma by dt into d square s by dt square divided by ds by dt whole cube. Okay, fine. So let us put this as equation number 3. Now let us compute what? Let us compute this quantity ds by dt and whole square. We know ds by dt is norm of gamma dt, and so this is its square, right? Yeah, I don't know how to put here. Correct. ds by dt, the derivative of the arc length, is nothing but the norm of the derivative of gamma. So, and we know norm of x square is, we can write it as inner product of or dot product of x with x. So this is same as gamma dot t dot gamma dot t, right? Then now differentiate this expression. Okay, we have ds by dt whole square equal to gamma dot t dot gamma dot t. So let us differentiate with respect to t. You have 2 times ds by dt into d square s by dt square is equal to gamma dot t dot, this is a product, right? So you have to apply product rule. So gamma dot t into gamma double dot t plus gamma double dot t into gamma dot t. So 2 times gamma dot t into gamma double dot t, right? This is fine, right? So this implies we can cancel out 2. So ds by dt into d square s by dt square is equal to gamma dot t into gamma double dot t. Okay, so let us put this as equation number 4. Then substitute equation 4 in equation 3. Kappa of t is equal to as equation 3. Yeah, so before that let us rewrite that equation. So before that let us do one thing. So consider equation 3 again. So this is the definition of classical example. Equation 3 was k of t is equal to norm of ds by dt d square gamma by dt square minus d gamma by dt into d square s by dt square divided by ds by dt square. So this again you on the right hand side you multiply and divide by ds by dt. ds by dt whole square t square gamma by dt square minus d gamma by dt into t square s by dt square divided by ds by dt raised to 4. Okay, now substitute. Now we can substitute equation 3, right? Okay, 1 ds by dt will be here. Yeah. So we know what is ds by dt square. ds by dt square is norm of, this is norm of gamma dot t square, and d square gamma by dt square is that is nothing but this thing, second derivative of gamma and gamma dot t, and from equation 4 ds by dt into this term is nothing but this term, right? Gamma dot t into gamma dot double t divided by, again this is ds by dt raised to 4, that will be it will be gamma dot t raised to 4. Okay, so again gamma dot t is nothing but norm of gamma dot t square is nothing but gamma dot t into gamma double dot t minus gamma dot t into gamma dot t gamma double dot, sorry, divided by norm of gamma dot t raised to 4. Okay, is that clear up to here? Any questions on this computation? Fine, right? Yeah. Okay, so now let us use again some nice property from vector calculus. So you have A cross P cross C. So this is same as A dot C cross, sorry, A dot C is a scalar, then you put cross A dot C into B minus A dot B into C. Okay, so this is a, if A, B, C are vectors, then for cross product, the cross product of A, B, C and the dot products are related by this relation. Here we take, here A is equal to gamma dot T, B is equal to gamma double dot T, C is equal to gamma dot T. So that K of T is equal to norm of what? This is of that form, right? A dot B into C. So this is actually gamma dot sorry, this is, I think this is A dot B cross C. Okay, so gamma dot T into gamma dot T cross and x is equal to summation A star xi. Suppose these A and B are equal, then this representation is called proper representation. No. This is actually the definition. I'm confused. I think 1 minute. Let me check. It's all proper representation. Second proper representation of X. That is summation X, yeah. Okay. Then there is unit. So sorry. That was precisely cross product only. A cross product will give you a vector, and on the right hand side this is a vector. Okay. So this is gamma dot t cross norm of gamma dot t cross gamma dot t divided by norm of gamma dot t raised to 4. So now norm of A cross B cross C is nothing but norm of A into norm of B cross C. Okay, so this will give norm of gamma dot t into norm of gamma dot t cross gamma dot t by norm of gamma dot t raised to 4. So this is equal to norm of gamma double dot t cross gamma dot t by gamma dot t cube. Okay. Now we are taking the corners part. Fine. Any questions? Also now we are taking that our class is any questions? So this is our formula. So yeah. So the point is, if you have a unit speed curve, its curvature is simply norm of its second derivative. Whereas if you have a regular curve, its curvature is, you should calculate its curvature by this formula. Okay, I'll repeat. If gamma is unit speed, then curvature k of t is nothing but norm of gamma double dot. If gamma is regular, then its curvature k of t is norm of gamma dot t, gamma double dot t cross gamma dot t divided by gamma dot t. Okay. So നമ്മൾക്ക് ഒരു കർവ് വന്നിട്ടുണ്ടെങ്കിൽ ഫസ്റ്റ് അത് യൂണിറ്റ് സ്പീഡ് ആണോ നോക്കുക, അതിന്റെ ഡെറിവേറ്റീവ് ആണ്, അതിന്റെ നോം കണ്ടുപിടിക്കുക. നോം 1 ആണെങ്കിൽ യു ക്യാൻ കമ്പ്യൂട്ട് യൂസിങ് ദിസ് ഫോർമുല. A of t is equal to norm of gamma double dot t. അല്ലെങ്കിൽ എന്ത് ചെയ്യണം, നമ്മൾ ഈ ഫോർമുല യൂസ് ചെയ്യണം. ഈ ഫോർമുല സെക്കൻഡ് ഫോർമുല യൂസ് ചെയ്യണം. ഓക്കെ, ദിസ് ഈസ് ഫസ്റ്റ് ആൻഡ് ദിസ് ഈസ് സെക്കൻഡ്. ഓക്കെ, വെക്ടറിന്റെ ക്രോസ് പ്രോഡക്റ്റ് എന്താണെന്നുള്ളത് നമ്മൾ അറിഞ്ഞിരിക്കണം. ഗാമ ഡബിൾ ഡോട്ട് ടി ക്രോസ് ഗാമ ഡോട്ട് ടി എന്താണെന്നുള്ളത് അറിഞ്ഞിരിക്കുക. രണ്ട് വെക്ടർ എക്സ് ഈക്വൽ ടു x1 x2 x3 y ഈക്വൽ ടു y1 y2 y3 എടുത്താൽ ഇത് ക്രോസ് പ്രോഡക്റ്റ് എന്ന് പറയുന്നത് എന്തായിരിക്കും? ഡിറ്റർമിനന്റ് ഓഫ് ഐ ജെ കെ x1 x2 x3 y1 y2 y3 ആയിരിക്കും. അപ്പോൾ കിട്ടുന്ന ഐയുടെ കമ്പോണന്റ്, അപ്പോൾ അതൊരു R3 വെക്ടറാണ്. ഐയുടെ കോഎഫിഷ്യന്റ് ഫസ്റ്റ് കമ്പോണന്റും ജെയുടെ കൂടെയുള്ളത് സെക്കൻഡ് കമ്പോണന്റും കെയുടെ കൂടെയുള്ളത് തേർഡ് കമ്പോണന്റും. ഓക്കെ, ഫൈൻ. Okay, now, yeah, so any questions? Any questions? Okay. ഞാൻ കുറച്ച് പയ്യെ സംസാരിച്ചത്, അത് അപ്പുറത്തെ വേറൊരു സാറ് ഒരു കോൺഫറൻസിന് പ്രസന്റ് ചെയ്യായിരുന്നു, അതാണ് കേട്ടോ. അപ്പൊ അത് കഴിഞ്ഞു എന്തായാലും. ഓക്കെ, now we'll do an exercise. Find the curvature of the circular helix. Okay, gamma theta is equal to a cos theta b sin theta, sorry, a sin theta b theta, theta belongs to R. real numbers. Okay. Find the curvature of the circular helix. Okay, this figure in R3 is called a circular helix about the z-axis. Okay, so ഇപ്പോൾ നമ്മുടെ ഒരു കർവ് വന്നിട്ടുണ്ട്, അതിന്റെ കർവേച്ചർ കാണാനാണ് ക്വസ്റ്റ്യൻ. അപ്പൊ നമ്മൾ എന്ത് ചെയ്യുക, ആദ്യം അതിന്റെ ഡെറിവേറ്റീവ് കാണാം. ഡെറിവേറ്റീവ് കണ്ടിട്ട് ഡെറിവേറ്റീവിന്റെ നോം 1 ആണെങ്കിൽ അപ്പൊ ഡെറിവേറ്റീവ് ആണ്, അതിന്റെ ഡെറിവേറ്റീവിന്റെ നോം കാണാം. ഇൻ കേസ് ഡെറിവേറ്റീവിന്റെ നോം 1 ആണെങ്കിൽ അതിന്റെ സെക്കൻഡ് ഡെറിവേറ്റീവ് സിംപ്ലി കണ്ടിട്ട് സെക്കൻഡ് ഡെറിവേറ്റീവിന്റെ നോം ആയിരിക്കും കർവേച്ചർ. അല്ലെങ്കിൽ യു ഹാവ് ടു യൂസ് ദിസ് ക്രോസ് പ്രോഡക്റ്റ് ഫോർമുല. ഓക്കെ, അപ്പൊ ഇവിടെ കണ്ടു നോക്കാം. ഇപ്പൊ ഇവിടെ വേരിയബിൾ തീറ്റയാണ്. സോ gamma dot t is minus a sin theta, b cos theta, and b. Norm of gamma dot t, gamma dot theta is equal to square root of minus a sin theta square plus b cos theta square plus b square. So this will be square root of a square sin square theta plus b square cos square theta. Okay, I made a mistake. This is a. It was second component was a sin theta. So this is a, this is a, and this is a. So this will be square root of a square into sin square theta plus cos square theta plus b square. So this is nothing but square root of a square plus b square. Right. So if a and b are non-zero, this is strictly greater than 0 if a and b are non-zero. Okay. And it in general നമുക്ക് എക്കും ബിക്കും കണ്ടീഷൻ ഒന്നും തന്നിട്ടില്ല. അപ്പൊ അതുകൊണ്ട് ഇതിന്റെ നോം 1 ആണോ എന്ന് അറിയില്ല. റൈറ്റ്. സോ we had to compute what? We have to compute second derivative, and you have to use that cross product formula. So the second derivative will be minus a cos theta, a minus a sin theta, 0. And what will be the cross product? Gamma dot t cross gamma double dot t cross gamma double dot theta cross gamma dot theta. This will be determinant of ijk, first component minus a sin theta. Sorry, it is second row should be the first vector, components of first vector. First vector is gamma double dot theta, so minus a cos theta minus a sin theta, 0, minus a sin theta, a cos theta, and b. Right. So if you compute this, you will get, you take the determinant, so it will be minus ab sin theta minus j into minus ab cos theta plus k into, let me write here, k into minus a square cos square theta minus 3 minus into minus plus, already there is a minus, so minus a square sin square theta. So this will be I into minus ab sin theta plus j into ab cos theta plus k into, if you want you can put a vector sign or ij cap, you to denote unit vector. Okay, it's not necessary if you want to identify or appropriately. So this is what will be this? This will be minus a square. So in component wise notation, this is same as minus ab sin theta. First component will be the coefficient of I cap, and the second component will be the coefficient of j cap, that will be ab cos theta, and third component is minus a square. So the norm of gamma dot theta cross gamma double dot theta cross gamma dot theta is equal to norm of this vector, norm of minus AB sin theta, AB cos theta minus A square. This is equal to square root of AB square sin square theta, AB square cos square theta plus minus A square whole square. So this is again the sin square theta plus cos square theta. You can take out AB square, and sin square theta plus cos square theta is 1. So that is square root of AB square, right, plus A raised to 4. So this is nothing but A square B square plus A raised to 4. So you can pull out A square, and square root and square will go out. So it will be mod A. A can be negative, right? So you are taking modulus of A square. What is modulus of, square root of A square? What is square root of A square? It is mod A, right? Correct? Is it A or mod A? You have any doubt? Square root of A square. I'll give an example. You think of it. Square root of minus 2 square. Find what is it. Okay, whether it is 2 or minus 2. So this is mod A into square root of A square plus B square. Right? Therefore, K of t is equal to norm of second derivative cross first derivative divided by norm of cube of first derivative. So this is mod A into square root of A square plus B square, and we already computed gamma dot theta is square root of A square plus B square. Norm of gamma dot theta square root of A square plus B square. So this is square root of A square plus B square whole cube. So this is precisely one square root will go there on the denominator, it will be square, and hence this is A square plus B square. So this is the curvature of mod A by A square plus B square. Okay. Is this fine? Any questions? Okay, very good. ഇതൊക്കെ നിങ്ങൾ ഓൾറെഡി ചെയ്തതാണോ? Okay. Yeah, good. Show that if the curvature K of t of a regular curve gamma t is positive for all t, then K of t is a smooth function of t. Also give an example to show that this may not be true. The case without the assumption K greater than 0. Yeah, I'll quickly give the answer. So let gamma be a regular curve. Okay, then okay, you assume this and assume k of t is positive. Now the function t goes to norm of gamma dot t q and t goes to norm of gamma double dot t cross gamma double dot t cross gamma dot t are smooth. Yeah. So we already seen norm of a curve is smooth if that is non-zero, right? I mean, what is norm? Norm of gamma dot t is nothing but square root of gamma 1 t square plus etc plus gamma n t square, right? So this function gamma is smooth, so each function gamma 1 gamma 2 etc gamma n are all smooth, so their square sum is also smooth, and we know the function x goes to root x is smooth on 0 infinity, open 0 infinity. So if this function inside function is non-zero, then this is the norm function is smooth. So therefore these functions are all smooth. Okay, so if k of t is strictly positive, then this quotient t goes to norm of gamma double dot t cross gamma dot t by this quotient function. Those two functions are smooth, so the quotient will be also smooth. Also smooth, right? So that is k of t is smooth. Okay, so let us see this counter example. So you want some curve for which this gamma of t is gamma of t can this curvature k kappa of t can be 0. So you take the curve gamma of t is equal to t cube. Consider the curve gamma of t is equal to t comma t cube. Then kappa of t is nothing but this. I am giving us an exercise. This you can see 6 times more t. You find the curvature of this curve, and I'll give the answer. The curvature is 6 times more t divided by 1 plus 9 t raised to 4 all raised to 3 by 2. This function, this k of t is not, or kappa of t is not differentiable at t equal to 0. Okay, fine. Yeah, this was actually exercise 2.1.2 in your prescribed text. Okay, so we'll see exercise 2.1.1. Okay, all questions are about finding curvature. So I'll give that an exercise, and I'll give the answer, final answer. You have to compute it. Compute the curvature of the following curves. Okay, so first one, gamma t is equal to 1 by 3 1 plus t raised to 3 by 2. 1 by 3, 1 minus t raised to 3 by 2, 1 by t by root. Okay. So this, if you compute the curvature of this curve, answer will be, this you have to do 1 by square root of 8 times 1 minus t square. Gamma of t is equal to 4 by 5 cos t 1 minus sin t minus 3 by 5, sorry, cos t. Answer is 1. And gamma t is equal to t cos ht. Cos ht by cos h cube t, or this is same as 6 square ht. Okay. And final one, gamma t is equal to cos cube t sin cube t. Answer is 1 by 3 mod sin t cos t. Okay, so you do these problems, you're not getting, please tell me, we'll discuss and try to do yourself. Okay, anyway, I gave the final answer, so you can try to reach to these answers. Okay, maybe I'll stop here. Any questions? Any questions or any comments or anything you want to ask? Any questions? സോ നാളെ 2 ദിവസം ഉണ്ടല്ലോ. അപ്പം മൺഡേയിലേക്ക്, നാളെ എന്തായാലും ക്ലാസ് എടുക്കാനാവില്ല, അപ്പം മൺഡേയിലേക്ക് 4 എക്സസൈസും ചെയ്യും കേട്ടോ. ഓക്കെ, വെരി ഗുഡ്. Okay. Okay, then you can stop. Yeah, I'm leaving. എന്തെങ്കിലും ചോദിക്കാനുണ്ടോ? സോ ഈ സാധാരണ റിപ്ലൈ അയക്കുന്നതിന് മാത്രമേ ഉള്ളൂ. ശരി, ഓക്കെ, then bye.